I am Dr. T. Swahasini, lecturer in physics, Government Degree College, Nagari, Chittoor district. Today, I explain the topic vector atom model. This topic is in 5th semester, paper 6, modern physics. What is atomic spectra? When the atoms are excited, they emit light of certain wavelengths it corresponding to different colors. The emitted light it can be observed as a series of colored lines with dark spaces in between them. This series of colored lines is called a line spectra or atomic spectra. So some drawbacks in Bohr's theory and Sommerfield's theory. So Sommerfeld and some other physicists, Uhlenbeck and Gauss-Smith, developed the vector atom model. So, vector atom model, the concept of is two postulates are there. One is space quantization, second one is spinning electron. First of all, why vector atom model is developed? So, drawbacks of Bohr and Sommerfeld theory. First one is original Bohr theory was it is incapable of explaining the fine structure of the spectral lines even in the simplest hydrogen atoms. Both the models are could not explain. Second one is in case of complex atoms, Bohr's theory fails to calculate the energy of the system and frequencies of radiation emitted. Both the models it could not explain the distribution and arrangement of the electrons in atoms. So both the models do not throw any light on the intensities of the spectral lines. Next one, both the models could not explain the Zeeman effect and Stark effect. What is Zeeman effect? When magnetic field is applied to the atom, each spectral line splits into several lines is called as Zeeman effect. And when electric field is applied to the atom, each spectral line splits into several lines is known as Stark effect. So to overcome all these drawbacks of Bohr and Sommerfeld's theory, Sommerfeld and Woolen and Goldsmith explain the two postulates. One is space quantization and second one is spinning electron. What is space quantization? According to the Bohr's theory, the electrons moves in a circular orbit. Hence, the electron has only 1 degree of freedom. In case of Sommerfeld elliptical orbits, electron possesses 2 degrees of freedom. An additional quantum condition is required to describe the actual state of the affairs. So, in vector atom model, the orbits are assumed. It's to be quantized in magnitude and directions both. According to the rule of space quantization, the electron orbit can have only set itself in certain discrete positions with respect to the field direction and not in all positions, making all possible angles with the field direction. So it was proposed by Sommerfeld. Second one is spinning electron. So what is spinning electron? Lindbergh and Gauss-Smith put famous hypothesis, that is electron spin. According to the hypothesis, the electron revolves not only in an orbit around the nucleus but also about its own axis. Thus, the electron has two types of motion. One is orbital motion, second one is spin motion. The angular momentum of the atom will now be due to the orbital and spin motion of the electron. According to the quantum theory, the spin motion like orbital motion should be quantized. Both are quantized. So, the orbital and spin motions are quantized not only in magnitude but also in direction. According to the concept space quantization, the two are considered as quantized vectors and hence the atom model is called as vector atom model. So the two fundamental postulates of vector atom model can have experimentally verified by Stern and Gerlach while they studying the behavior of atoms in non-homogeneous magnetic field. Next one is quantum numbers associated with vector atom model. So 7 quantum numbers are associated with this model. First one is principal quantum number, second one is orbital quantum number, third one is spin quantum number, fourth one total angular quantum number, fifth one magnetic orbital quantum number, sixth one magnetic spin quantum number, seventh one magnetic total angular orbital quantum number. First one, the principal or total quantum number n. The quantum number, it belongs to the principal orbit, it which the electron belongs, and its small n, and it is identical that used in the Bohr-Sommerfeld theory. So it was represented by small n. The principal quantum number small n can have only non-zero positive integrals, that is n is equal to 1, 2, 3 dash dash to infinity. The energy levels are cells of electron corresponding to n is equal to 1, 2, 3 to 7. It was denoted by letters K, L, M, N, O, P, Q respectively. The number of electrons in a shell is limited to 2 n square. Second one is orbital quantum number L, small l. This quantum number defines the shape of the orbital. It is occupied by the electron, and the orbital quantum number of the electron, it is from 0 to n minus 1. This value refers to subcell. The orbitals corresponding to L is equal to 0, 1, 2, 3 to in x. It was designated as small letter S, P, D, F, etc. Next one, the orbital quantum number L, it is similar to the azimuthal quantum number n5 of the Sommerfeld theory. The two are related by small l is equal to n5 minus 1. Third quantum number, spin quantum number. The quantum number was introduced to account for the spin of the electrons about their own axis. The magnitude is always half, since the electron can spin clockwise or anti-clockwise. There are two values given to S, plus half and minus half, depending upon whether the electron spins in one direction or other. Two electrons with the same sign of spin quantum number are said to have parallel spins, while these have opposite spins of spin quantum number are said to have opposite spins or paired up spins. Next one, total angular quantum number J. This quantum number represents the resultant angular momentum of the electron due to both orbital and spin motions. Its numerical value is vector sum of L and S. It is usually expressed as J is equal to L plus S, J is equal to L plus half sign is used, S is parallel to L, and J is equal to L minus 1 by 2. Minus sign is used when S is anti-parallel to L, where every L value except that for which L is 0 is consequently split into two levels with different energies. So this explains the fine structure of the spectral lines. Although the number of lines is limited, selecting rule delta J is equal to 0 or plus or minus 1. Total magnetic orbital quantum number ml. When an atom is placed in a strong magnetic field, the electrons with same values of principal quantum number n and orbital quantum number L in different directions, and the magnetic moment is divided into orbital magnetic quantum number ml and spin quantum number ms and total angular magnetic moment mj. So the orbital magnetic moment number is varies from plus L to minus L. So for each value of L there will be 2L plus 1 possible values of ml. for L equal to 0 and ml is equal to 0, and for each value of the principal quantum number n, that is there is only one orientation, that is s orbital, and for L is equal to 1, ml is equal to 3 orientations are possible, that is plus 1, 0, minus 1. And next for L equal p orbital is possible. For L is equal to 2, ml is equal to plus 2, plus 1, 0, minus 1, minus 2. That is 5 permitted orientations are possible. And that is f s p d orbital. For L equal to 3, ml is equal to plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. That is 7 permitted orientations are possible. F orbital. So next one, magnetic spin quantum number ms. So the value of ms varies from minus s to plus l excluding 0. Thus for each value of s can have only two values, plus 2 and minus plus 1 by 2 and minus 1 by 2. Last one, magnetic total angular orbital quantum number mj. The value of mj varies from plus j to minus j excluding 0, and it possesses only half integral values. This explains the splittings of spectral lines in a strong magnetic field. This So in our syllabus there is no experimental verification, space quantization and electron spin, Stern-Gerlach experiment. Thanks for attention.